A length of steel conduit tube is cut to size. The freshly cut end is then rethreaded using a stock and die set and will need to be deburred, the removal of sharp edges which can damage cables during installation. Additional accessories are introduced, such as solid bends which create a 90-degree change of direction to the system. An alternative way to achieve this is by physically bending the length of conduit using a dedicated tube bender. The cut length is attached to its start point. For example, an adaptable box using either a male brass bush and coupler or a female brass bush and 2 lock nuts. Saddles are used to support the tube. We recommend one saddle every 1.2 meters when installing 20 or 25mm conduit to ensure a secure fixing. Steel conduit boxes, inspection elbows, bends or tees can be installed into the system to alter the direction and create access points for ongoing maintenance. These are used throughout the system and feature a bright zinc plated removable cover for inspections. The conduit will eventually terminate once it reaches its end point, in this case a switch and socket box. Cable is then pulled through the system using draw tape, also known as fish tape. The installation of box lids finalises the system and protects the cables inside. Steel conduit tube can be found in a wide variety of structures, with industrial buildings being the most common setting. Other applications include commercial offices, power plants such as biomass, nuclear and recycling, government-led projects, for example airports, car parks and Ministry of Defence buildings. Another common environment for steel conduit tube systems is rail, with thousands of lengths required to carry cables through the networks such as the London Underground. The large Crossrail project in London also makes significant use of these systems as new railway lines are built. Steel conduit tube systems also offer an industrial aesthetic which has become extremely popular in recent years. Often you will see these lengths running overhead in your favourite coffee shop or modern barn conversions. The current standard for steel conduit tube systems is BS EN 61386-1 2008. At Metpro, all our steel conduit tube and accessories are manufactured in accordance with this standard, from dimensional tolerances to the surface finishes. Our hot dip galvanised conduit is also manufactured to Class 4, the highest class within BS EN 61386, and offering the highest levels of corrosion resistance, impact, compression and tensile strength. In January 2020, an addition to this standard was introduced. Entitled Plus A1 2019, the predominant change of this update was the requirement for additional markings on each length of conduit. Consisting of 4 numbers, each one corresponds to a grade within the standard as detailed in the image shown here. Metpro steel conduit tube is fully compliant to this latest update and to the highest classification. Focused solely on rigid conduit systems, our innovative Conduit range is fully compliant to all relevant requirements of BSEN 61386-21 2004 and has been used in multiple major projects such as Heathrow Terminal 2 and the Sir Chris Hoy Velodrome. In addition to the British standard, London Underground authorisation is another mark of quality for steel conduit and the relevant accessories. Metpro tube and applicable accessories are fully authorised to London Underground Standard 1-085. This ensures that our tube and accessories can be used in London Underground projects in both surface and subsurface installations.